Hello there, Cardinals. It's me, Mr. Ernst, and in this video we are going to be talking about similar triangles. I want to emphasize that similar triangles comes from our previous video, which was all about dilations. In other words, we're taking this small triangle, or the large triangle, and we're changing its size. So beforehand we learned how to actually dilate a shape. So it's kind of expanding, it's growing in size. And now we're actually going to be looking at how we can work with similar shapes. And specifically, we're going to be focusing on triangles. So when we're looking at this, beforehand we were looking at basically the points, point A, B, and C. But in this example, we're actually going to be looking at the side lengths once again, this side, and this side, and how they correlate from one side to the other. So one trait about similar triangles is the fact that you do have to maintain a scale factor for all sides. All three sides, or all sides of whatever shape you're working with, have to obey the scale factor. And I'm going to show you what I mean here. For this small triangle, I'm going to put this one in, we'll do this red. I'm going to write out its three side lengths. Actually, you know what, let's do this in black. 3, 4, 5, from smallest to largest. And this is my small triangle. Small triangle, okay? For my larger triangle, and I'm kind of just writing this out so it's, ooh, that's ugly. Whoop, let's try that one more time. Gosh, can't manage to. There we go. For my larger triangle, again, I'm kind of just creating two tables. For my larger triangle, I have the side lengths of 6, 8, and 10. Now, some of you may already see what the scale factor is going to be in between these two triangles. Notice, for both of these triangles, I did exactly the same thing. I wrote out their three side lengths, 3, 4, 5, in ascending order, in other words, as they got bigger. And this one I did 6, 8, and 10, once again, in ascending order here. And the reason for that is that this is automatically going to match what is called our corresponding sides. In other words, when this dilated, 3 turned into a 6, 4 turned into an 8, and 5 turned into this 10. And that's important because this is what's going to tell us what our scale factor is. And again, we can see this very clearly over here. 3 turned into 6, 4 turned into 8, and 5 turned into the 10. So each one of these kind of turned in this way. Okay? And now, again, because they are similar triangles, they all have to use the same scale factor. So 3 multiplied by what number is going to give me the number 6? 2. 4 times 2 gives me 8, and 5 times 2 gives me 10. So the scale factor for this dilation was 2. That's how we know these are similar triangles. So 5 had to multiply by 2 to get to 10, 4 had to multiply by 2 to get to 8, and 3 had to multiply by 2 to get to 6. Cool? That is what makes a similar triangle. So now let me give you an example of a triangle that's not similar. Again, we have 3, 4, and 5, but this time we have 6, 8, and 15. Once again, the 3 becomes the 6, it's times 2. The 4 becomes the 8, which means it's multiplying by 2 as well, but this time, our 5 multiplied by a 3. That's how we know these are not similar triangles. They are not similar because all 3 of them would need to have the same scale factor. Again, if I was to write this out, 3, 4, 5, and on the other side it's going to be 6, 8, and 15, we'd have a 2, and then a 3. This breaks it. We can't have a scale. This is no longer similar triangles. It does not work that way, okay? So that's one thing we can look for when we're looking at similar triangles. And we can actually use that scale factor to find a missing side length, kind of like what we were doing with the Pythagorean theorem, but this time we can use it on, get this, any kind of triangle. So here's an example of 2 obtuse triangles. This one, these are similar, so I'm telling you these are similar triangles, okay? Which means that this triangle was dilated to make this larger triangle. On this small one, we know we have a 1, and a 3. So I'm even going to write those side lengths out. On my smaller triangle, I have a 1, and a 3. Again, going from the smallest number to the largest. And on my larger triangle, I have an x, a 3, and a 9. So I'm once again going to write these out together. We have an x, a 3, and a 9. Now notice again, these are obtuse triangles, but similar triangles still can find a missing value because we can follow the scale factor. So again, Pythagorean theorem only useful on right triangles. Similar triangles can be any kind of triangle, obtuse, acute, or right triangles, any one of them. So again, looking at my scale factor, I don't know what this is. X multiplied by blank gives me, I don't know what this number is. I'm trying to find out what x is. But let's see, we have 1 times blank gives me 3, and 3 times blank gives me 9. And remember, this is similar, so they are all going to have the same scale factor. Okay? So I can use these clues. 1 times blank gives me 3. Well, this number would have to be the number, I can release these. This has to be the number 3. I can even double check it down here. 3 times blank gives me 9. This would have to be 3 as well, which means if these are similar triangles, this would have to be a 3, which means my missing x value, 1 times 3, would be 3. So my missing x value up here, my missing x value would be the number 3. So the two triangles that I have is going to be 1, 1, 3. And after it's been scaled up by 3, it's been tripled in size, we have 3, 3, 9. Okay? So once again, what I like to do, my steps, lay out all 3 of the side lengths in descending or ascending order, doesn't matter which. Find the scale factor and then use that to find the missing value. Our last example is a little bit more tricky. Now, this looks a little bit weird, but what I want you to visualize is we actually have our two triangles laying on top of each other. Okay? So for the orange one is this large triangle, right? 1, 2, 3. Is this really big triangle here, okay? And the orange triangle, whoops, didn't mean to bring those back. The orange triangle, and I'll actually write these out in the color orange, has lengths of 5, 6, and 8. So once again, my big triangle has 5, 6, and 8. And again, I'm telling you these are going to be similar triangles. I want you to find the missing x and y value. For my blue triangle, down here, we have sides x, 3, and y. And again, remember, this is just a blue triangle that is just sitting on top of this orange triangle. I could separate these if I want to. So it's a blue triangle sitting on top of an orange triangle. So 3, x, and y. On this one, I can see x is on this side, so x corresponds to 5. So the x is going to correspond to 5. The 3 is going to dilate to become the 6. So the 3 lines up with the 6. And the y is kind of the hypotenuse of this thing. It kind of looks like a right triangle a little bit. So y is kind of this long side, so y is going to correspond with the 8. So y is down here. Now, beforehand we had 2 examples, but you actually only need just one. 3 multiplied by what number is going to give me 6? Well, the answer is 2. So the scale factor to get from my blue triangle to my orange triangle is multiply by 2. And since this is a similar, or these are similar triangles, that means that all of them have to be multiplied by 2. So for example, my y value, what number times 2 is going to give me 8? Y must be equal to 4. 4 times 2 gives me 8. So this length right here, from here to here, is 4. Up here we have this x value. X multiplied by 2 is going to be 5. Well, what number multiplied by 2 is going to give me 5? Or in other words, what is half of 5? And that would come out to be 2.5. So my missing x value over here is 2.5. And that is from here to here. Cool? So in this case, my answers would be x is equal to 2.5 and y is equal to 4. Cool? And that is us starting off using similar triangles. Again, we are using what we do know. We're going to use one example to be able to find our missing values. And we do that with all sorts of different triangles there. But yeah, that is the beginning of how we can work with similar triangles. Thanks for watching.